Hi everyone, I'm Connor, and today we're going to talk about the Transfer Learning and Fine-Tuning Lab. In this lab, you'll be asked to perform transfer learning on an image classification dataset of your choice using a pre-trained ResNet and on a text dataset using a pre-trained GPT-2. For transfer learning, we take a network that's already been trained on a given task and train it on a different task. This then allows us to produce a network that can perform well on the second task, significantly cheaper than if we had just trained a new network from scratch. Luckily, PyTorch has a lot of pre-trained networks that we can use. In particular, in this lab, we will be using ResNet 152, which is a very large ResNet architecture. This network has been trained on the very large ImageNet dataset. The reason why transfer learning is so useful is because it allows us to reuse features that were learned on one dataset and use it for a different dataset. In convolutional neural networks, the earlier convolution layers often learn very simple features. Usually they perform edge detection like most of these features that you see on the left here. And as you go further along in the network, these features combine into creating more complex features that can be used to detect more complex patterns and objects in the image. However, for most image classification tasks, the earlier layers can be the exact same. So you don't need anything fancy or anything specifically tailored towards a single data set. As long as we've learned these earlier layers, they're most likely going to be useful for any image processing that we'll do with a neural network. However, the later layers, especially the output layer, like the linear layer that you see on the right, these usually aren't going to be useful to us, especially since an output layer maps some of the image information into a class prediction, and even if we have a data set that has the exact same number of classes as the data set that our network was trained on, the neurons will still represent different classes, and so we'll need to completely replace this layer, and we'll need to focus a lot of our learning simply on changing the last layer of the network so that we can have a valid output layer. Performing fine-tuning is actually pretty simple. Here we have a diagram of VGG19, which is not the network that we're going to be using, but it'll be used to illustrate the same principles that we'll be using on the ResNet 152. So the first thing we want to do when we fine-tune a pre-trained network is replace that final learned output layer. So here we turn the linear layer we replace the linear layer with a new linear layer that maps to however many classes that we have. For the ImageNet problem, and so for the pre-trained network that you'll be getting, it'll be mapping it to 1,000 classes, but for example here we're just mapping it to 10 or to however many output classes you choose to have. The next thing that we want to do is we want to freeze all the layers except for that last layer. And what freezing means is basically we're just setting the requires grad parameter on each of the layers parameters to be false, and that means that that those layers of the network won't learn. Those parameters will not be updated. They will not be updated by the optimizer. And so we spend a certain amount of time, in this case 1 epoch, training just this final output layer, because as we train the network, that's the only thing that will be updated since all the other layers are frozen. And then once that is trained, we then unfreeze the layers going from right to left, or going from output to input. So this linear layer will be the next one we unfreeze, and then we train on that. We then unfreeze this linear layer, and so on until we get to a point where we just decide to stop. And the reason why we do this is because the earlier layers are most likely to have learned things that are more general and will be more generally useful towards image processing tasks and other similar tasks. So we don't want to change those as we change the output layer, because we know that the output layer is going to map it basically to nonsense, even if it can understand what the image is, because it'll be acting like it's being trained on the original task, even though the data will not be reflecting that. And so because of that, we keep the earlier layers constant while we just train the newer layers. And once the newer layer is correct enough for the task, then we can go backwards and fine-tune those later layers along with one of the earlier layers too. And we could do this for the entire network for each of these layers, but usually the earliest layers will be completely general and completely useful for any image recognition task that we have. So often we'll just stop after an arbitrary number of layers. And that should be everything that you need to know to perform transfer learning on the ResNet. You'll also be asked to perform transfer learning on GPT-2. However, you're already given a method to do so, and you just need to pass in your own data set to do that. This lab should be shorter than the others, so make sure that you use that extra time to work on your final projects. If you have any questions, be sure to come and ask the TAs either during our office hours or on Slack. Good luck.